Hello everyone, my name is Neil Thomson. I'm with the Department of Civil and Environmental Engineering at the University of Waterloo, located in beautiful Waterloo, Ontario, Canada. At this point in the course, we're going to be discussing ways to remediate or clean up sites. So the focus of this segment and the following two segments providing an overview of ways to clean up sites or ways to remediate sites. So the overview consists of why do we want to remediate a site or clean up a site, what are the possible remediation objectives, and then more importantly, what are the possible options or alternatives for us to use to clean up the site. So again, as I said, today's or the first opening segment is on why we want to remediate a site. So we sit here and we ponder that question on why would anybody spend money on trying to clean up a contaminated site? Well, let me begin with a very simple example on why you may want to do this. A typical one is a brownfield site, which is an old industrial site that occupies a very important urban area that is not being used. You can take a brownfield site and with some work demolish the site into piles of sand and concrete and debris. Walk around the site. Here's the site in my safety equipment. Walk around the site and with some help of some pipes and some wells and a chemical oxidant, you could take a site that was heavily contaminated with trichloroethylene and polychlorinated biphenyls or PCBs and have the site to be deemed clean by the Ontario Ministry of Environment. And that then brings you to why you want to clean up the site, because you take a very ugly brownfield site, a very unsafe portion of a urban landscape, and convert that into, perhaps in this case, into a very viable and thriving tax center for the municipality to be able to collect taxes. And in this case, the consultant and the developer were able to take the site and convert that into a nice arrangement of townhouses, I believe, on this site. A very viable place for people to now live and work out of. So then, why do we want to clean up sites? What is the ultimate purpose? Perhaps the client would like to purchase land, or in the cases I just spoke about, perhaps it's a development site for brownfields. There may be off-site impacts caused by some contamination problem that has gone off-site. There may be a legal or regulatory requirement to clean up the site. In some cases, there's a public perception or stigma that the actual site is a contaminated site and would then have to be cleaned up, and that might be just purely from an aesthetics perspective. There is the potential for impact of off-site resources, perhaps a receiving water body is close by. Some site owners clean it up for just goodwill, and there are perhaps others. So if the risks are unacceptable, then a remedial action will need to be taken. So here we have a very simple case of a source, a pathway, and a receptor, which is somebody perhaps drinking the water or eating the fish. So it's a way to protect human health and the environment from a problem between a source, pathway, and a receptor. There are many possible pathways. On this slide, we have a soil to groundwater pathway where we have a contaminated portion of a soil just below the ground surface there in red. We have a groundwater plume that gets formed, and we have a pathway between the source area, the plume, and an abstraction well, which somebody may be using as a drinking water supply. Other pathways are perhaps a groundwater-only pathway where we have the source within the aquifer. That might be a non-aqueous phase liquid source or a NAPL source develop into a dissolved phase plume, and then the pathways between the source, the plume, and again the abstraction well on the far side. In other instances, we may have a contaminated part of land that's above the water table in the unsaturated zone that may contain volatile organic compounds, and then these compounds will, through a phase change or have a higher vapor pressure, create a gas phase that could enter an indoor air environment. So we have a soil to indoor air pathway. We could also have the very similar case of the source located below the groundwater table, and in that case we would have a source to the groundwater area or a groundwater to indoor air pathway. So we have these range of possible pathways that exist between a source and a range of possible receptors. The cleanup criteria then for each site depends on the possible pathways, either real or perceived, the type of receptors that are present, obviously the type of contaminant that's there, because that will then dictate the behavior of the compound. Also depends on the toxicity, the aesthetics, and the underlying or baseline or background concentration at the site. And hence, to create a linking between the source and the receptor, there's simple source receptor modeling that is used to again link between a source concentration and a receptor concentration. There are three basic ones used. There's cleanup to background, there's a generic level that's prescribed across all sites, or for the more sophisticated or more complex problems, there would be a site-specific risk assessment that would need to be performed. These pathways then end up in regulatory criteria that are published, tables like the one on this slide for groundwater to indoor air or GW2 pathway for the Ontario Ministry of Environment. Again, for all of the compounds are in the list here, and on the far right hand side you will see the proposed standard for this particular pathway for a generic case where we have medium to fine texture soil present. A key understanding of remediation lies at the heart of what is called a conceptual site model, or a CSM, and it's a fundamental starting point for a valid assessment of the risk posed by contaminated soils and groundwater. It is clearly required for site cleanup or site remediation. You have to have a clear understanding of where the sources are, what forms they're in, and what impacts that they may have. The subsurface transport is a very complex process, and it is a migration pathways that are complex and have multi-process transport phenomena involved. Perhaps for one site there would be several basic conceptual site models that might apply for, again, for a single site. So there's not just one conceptual site model that is possible. Based on the available data, there maybe a few that apply that would still honor all of the data in hand with the site. But what is a conceptual site model itself? It's a way to organize and communicate information about the site characteristics. Such basic things as geology, hydrogeology, the source characteristics of the site, the area impacted, perhaps the presence of a non-aqueous phase liquid, any other contaminants that are present. It would also then explore the migration or the exposure pathways and the potential receptors. It would also include details about the aquifer materials that are present, and also include something about the contaminant site-specific properties such as absorption potential, redox properties, etc. It's always based on the best interpretation of the data that is available at the time. As other data are collected that become inconsistent with the current conceptual site model, then the conceptual site model needs to be revised. And again, and more importantly to the specific point of our discussion here today, these remedial activities have to be consistent with the site conceptual model or the conceptual site model. Here's a example then of a conceptual site model. The best way to convey this is through a very simple schematic of the site, showing the various types of stratigraphy at the sites, and a sketch of the perceived behavior of the contaminants at the site. Here we see an old creosote yard showing the dissolved phase plume and showing various degrees of non-aqueous phase creosote that has gone down through the unsaturated zone up in the superficial aquifer and is now pooling on top of some clay zones at depth. The goal of a site cleanup or a remedial effort is to target the mass. So the question is, where is the mass and where is my targeting of the mass? Well, unfortunately, contaminants can be in one of the four following phases. They can be in the free phase or the non-aqueous phase. They can be in the aqueous phase or dissolved phase. They can be in the gas phase or nacre phase, or could be absorbed onto or inside the aquifer drains, and that would be a solid phase. Each of those phases, except for the solid phase, may be a mobile phase. Perhaps you have a non-aqueous phase that has not come to a state of rest yet, and perhaps may be able to flow. Dissolved plumes obviously are a concern, and vapor plumes are obviously a concern as well. So the goal then is to target the mass. If the problem happens to be a dissolved phase plume, then you have a problem of the mass having to flow away, as opposed to a static problem where you may have non-aqueous phase that has come to a state of rest and is fixed. So those are two clearly different ends of the perspective here. Sometimes if you travel around your urban landscape, you see structures around that have been abandoned for quite some time, and you question yourself, why do these structures sit idle? Here's an old factory structure that made electronics parts for a company called Electrohome. Sits within a nice urban area, green trees all around it, but yet it's not used for anything. So you scratch your head and you say, why is this structure still here? Why hasn't somebody bought this? Likely there's a contamination issue here. And since it's not being cleaned up, likely there's a long-term problem here. So it gets down to where's the mass. So you have to have some idea of where that key mass is. You need to be able to target that mass to actually do some treatment on the site so that the site can become clean. Again, the geology is very complex, and superimposed on the complex geology or stratigraphy at the site is that the contaminants themselves are very heterogeneous in nature, so we have a complex geological system. Superimposed on that, we have a heterogeneous contaminant distribution, a very complex problem for many sites to clean up. We also need to consider that where is the mass, what's the scale of the problem? Well, if we have a non-aqueous phase liquid problem, ample will likely be very close to the site. Aqueous plumes can be between meters and kilometers in length. Some of the mass, as I spoke about, can be absorbed to aquifer solids, and in some cases the mass could be diffused or invaded into low permeability zones. So here's an example of mass that has gone into a lower permeability zone. So the sketch here is a sketch of a lower permeability lens in brown and a more permeable zone in blue. So as the mass comes in from the left-hand side of your screen, it will flow around the lower permeability lens like a clay, and then as the plume sits there, it will diffuse slowly into the lower permeability lens, and in the end the lens then will store mass, and then as you clean up the source area, these lenses or these low permeability features then will bleed back and be a long-term contaminant source themselves. The diffusion process into the lens at the start is very high because the concentration gradients are extremely steep, and it would take equal or more time for that mass to then diffuse out of these zones. So these, as my note says here, are slow release and act as a long-term source. And again, that process is diffusion controlled. So if you go around again to your urban areas, look around your areas, you can see that tucked away behind storefronts are trailers and garages and shacks that sit there, and you scratch your head and you say, why does this one say Hasco on it? It seems to be here for quite some time. It has a very strange feature up on the roof. In fact, this is a groundwater extraction system for a pump and treat, and has sat there for a long time. As you then explore around the site, you can see wellheads and a sump area that is used for this particular cleanup approach at this site. Again, as you see around other storefronts, you'll see other bits around, perhaps parked behind a garage. You see a shack with a vent. This is a soil vapor extraction facility in place. You go up to it, you can again see that it's not a permanent structure, it's a temporary structure, but has been there for quite some time. So that's a very quick overview of why we would like to remediate or clean up the root causes of that. We spoke a little bit about the conceptual site model. We spoke about the need to target the mass. We spoke about ways that the mass is stored, and we spoke about the long-term effects of lower permeability zones. The next segment we'll be talking about the goals or the objectives of the remediation process, what we would like to achieve, and the following segment after that will be speaking about the technology options. Thank you, and I look forward to seeing you in the next segment. Bye.